The 1/4-inch factory knockout found in NEMA 1 panels, such as square DQ row and homeline panels, is primarily designed as an auxiliary knockout for conduit to enter the panel. While the main purpose is for conduit entry, this knockout can also serve secondary functions. Firstly, it can be used for mounting a 1/4-20 bolt for a lug. In this case, a 1/4-20 bolt can be inserted through the knockout to mount a terminal lug or other attachment point within the panel. Secondly, it can be utilized for grounding, specifically to pass the equipment grounding conductor, or EG, into the panel. However, it's important to note that using the knockout for grounding is generally not recommended as the primary method, as it does not offer a secure and code-compliant connection. Relying solely on the knockout for grounding could potentially lead to safety issues and code violations. Thirdly, some electricians use the knockout as an additional weep hole to allow moisture to drain from the panel. This is not an intended use and its effectiveness can vary. The primary purpose of the knockout as an auxiliary conduit knockout is generally supported by industry standards and best practices within the electrical industry. However, the secondary uses mentioned, such as using it as a weep hole or for grounding, are not explicitly documented by manufacturers or code bodies. Therefore, it is generally recommended to primarily use the 1/4-inch knockout for its intended purpose, which is conduit entry. If necessary, it can be used for the secondary purposes mentioned, such as mounting a lug, but it should not be relied upon as the primary means of grounding or drainage. Always adhere to electrical codes and regulations when installing or modifying electrical panels. It is important to consult the NEC, which stands for National Electrical Code, and any local amendments for specific requirements and guidelines. In terms of grounding, the NEC specifies methods for properly grounding electrical equipment and systems. These methods typically involve using approved grounding conductors, connectors, and grounding electrodes to create a low impedance path for fault current to return to the source. Using the 1/4-inch knockout for grounding, without proper connections and hardware, may not meet the requirements of the NEC. It's also important to consider the environment where the electrical panel is installed. In damp or wet locations, moisture can accumulate inside the panel, potentially leading to corrosion or electrical faults. While using the 1/4-inch knockout as a weep hole may seem like a simple solution for draining moisture, it may not be effective in all cases. The weep hole may become clogged with debris or not provide sufficient drainage to prevent moisture buildup. If moisture is a concern, it's important to address the source of the moisture and take steps to prevent it from entering the panel. This may involve sealing any openings in the panel, using a weatherproof enclosure, or providing adequate ventilation. When installing conduit into the electrical panel through the 1/4-inch knockout, it's important to use appropriate fittings and connectors to ensure a secure and watertight connection. The type of fitting or connector will depend on the type of conduit being used, such as rigid metal conduit, electrical metallic tubing, or flexible metal conduit. It's also important to ensure that the conduit is properly supported and secured to prevent it from pulling or straining the knockout. Over time, vibrations or physical stress can damage the knockout or the conduit connection, potentially leading to electrical hazards. When mounting a lug to the electrical panel using the 1/4-inch knockout and a 1/4-20 bolt, it's important to ensure that the lug is properly sized for the conductor being terminated. The lug should also be made of a compatible material to prevent corrosion or galvanic action. It's also important to tighten the bolt securely to ensure good electrical connection. A loose connection can generate heat and lead to a fire hazard. It's also important to consider the ampacity of the conductors being terminated at the lug. The lug should be rated for the maximum current that the conductors are expected to carry. Overloading the lug can cause it to overheat and fail, potentially leading to a fire hazard. When working with electrical panels, it's always important to follow safe work practices and wear appropriate personal protective equipment, or PPE. This includes wearing safety glasses, gloves, and insulated tools. It's also important to de-energize the circuit before working on the panel. Verify that the circuit is de-energized using a voltage tester before touching any wires or components. If you're not comfortable working with electricity, it's best to hire a qualified electrician to perform the work. Working with electricity can be dangerous, and it's important to take all necessary precautions to prevent injury or property damage. Also, consider the panel's listing and labeling. NEMA, which stands for National Electrical Manufacturers Association, ratings define the type of environment an enclosure is suitable for. A NEMA 1 enclosure is intended for indoor use and provides a degree of protection against contact with the enclosed equipment. The UL, which stands for Underwriters Laboratories, listing indicates that the panel has been tested and meets safety standards. Always refer to the manufacturer's instructions and documentation for specific information on the panel's intended use and limitations. Improper use of the panel or its components can void the warranty and create a safety hazard. Finally, remember that electrical codes and regulations are constantly evolving. It's important to stay up to date on the latest requirements and best practices to ensure that electrical installations are safe and compliant. Consult with a qualified electrician or electrical inspector if you have any questions or concerns.